Hello everyone. In last session we have solved some problems based on right circular cylinder. Now in this session we are going to solve one problem based on right circular cylinder where the radius is not given to you. Okay, the equation of axis is given and instead of radius they have given one point which passes through which the cylinder is passing, right? We are going to follow the regular procedure, that is using the Pythagoras theorem only. I am going to figure out what must be the equation of right circular cylinder. The regular procedure meaning, this is my cylinder, axis of the cylinder is given to you, this is axis, right? Now using the axis, two things I can figure out, that is the point through which axis is passing and the direction ratios of the axis, right? So the given equation of axis is x minus 2 upon 2, y minus 1 upon 1 and z by 3. So therefore axis passes through the point 2, 1 and 0. So let's name that point. Let's take A as equal to 2, 1 and 0, right? So I'm having A point here somewhere, say the point is 2, 1, 0. Okay, then using equation I have direction ratios of axis and these are 2, 1 and 3, right? Using direction ratios I can find out direction cosines. So that is 2 divided by 2 square plus 1 square plus 3 square. So 4 plus 1 plus 9. Then 1 upon again 4 plus 1 plus 9. Then 3 upon again 4 plus 1 plus 9. Right? So this is equal to 2 upon root 14, then 1 upon root 14 and 3 upon root 14. So these are my direction ratios, right? The next thing we are going to do is consider any point P, say XYZ on the cylinder, draw perpendicular on axis from the point, say foot of the perpendicular is M. Then join this AP so that I am having here right angle triangle AMP, and using this right angle triangle I am going to figure out equation of cylinder, right? Now since radius is not given to us, we are going to consider PM is equal to R, right? So let's take PM, which is radius of cylinder. Let's take it R. Right, so this is first length. The second thing we are going to figure out using distance formula, length AP. So what is length AP? Length AP is square root of x minus 2 square plus y minus 1 square plus z square, right? So this is second length. And the third length AM is nothing but projection of AP on axis line, right? So how to figure out this projection? Using the formula which we have studied, that is L into x2 minus x1 plus m into y2 minus y1 plus n into z2 minus z1, where L, M and R direction cosines of axis and x1, y1, z1 is the point P and x2, y2, z2 is the point A, right? Let's substitute the values. So this is 2 upon root 14 into x2 minus x2, so x minus 2 plus 1 upon root 14 y minus 1 plus 3 upon root 14, so that is z minus 0 is z. Let's simplify this little bit. this is equal to 1 upon root 14. I can take common. So inside 2x minus 4 plus y minus 1 plus 3z. So what is it equal to? 1 upon root 14. 2x plus y plus 3z minus 5, right? So this is third length. Now I got all the three sides for the right angle triangle. Now I can apply Pythagoras theorem to find out equation of cylinder, right? Let's do that. So equation of cylinder is in the triangle applying Pythagoras theorem. So an square plus pm square, this is equal to ap square. Just to retain a number on one side, I'll write down the equation as ap square minus am square, this is equal to pm square. Let's substitute all the lengths. ap square is now x minus 2 square plus y minus 1 square plus z square. Since I'm squaring, square root will get removed, right? Minus 1 by root 14 square will be just 1 by 14 into 2x plus y plus 3z minus 5 whole square, and on the right hand side this is a r square, right? Since pm is r. Now the next thing, we are going to just simplify the equation little bit. Okay, let's simplify this. Multiply by 14, so that this is 14 into x square minus 4x plus 4 plus y square minus 2y plus 1 plus z square. 14 I am multiplying, so this will get cancelled. Minus the square is 4x square plus y square plus 9z square plus 25, and this into this is 4 times xy plus 12 times xz minus this into this 10, so 20 times x, then this into this is 6 times yz, then minus 10 times y, and then the remaining term is 30 times z, and this is equal to 14 times r square. Alright, now this is more simplified thing. Then I can write down this as 14 minus 4, so 10x square, then again 14y square minus just y square, so this is 13y square, then 14z square minus 9z square, so which is 5z square. And now what are the remaining three things? This is minus 56x, then minus 28y, and this is 5 into 14 is 70, then minus, we are done with this one, this is minus 25 minus 4xy minus 12xz plus 20x and minus 6yz plus 10y plus 30z equal to 14r square, right? Now note that they have given one thing. See this is equation 4. They have given one thing, that 0, 0, 3 is the point through which cylinder is passing. That is somewhere here I am having 0, 0, 3 point, right? So if it is on cylinder, that means it should satisfy equation of cylinder. That is, we can substitute x is equal to 0, y equal to 0 and z equal to 3 to get value of r square, right? So since 0, 0, 3 lies on cylinder, equation of cylinder satisfies satisfied by 0, 0, 3, right? So let's substitute. X is equal to 0, y equal to 0, and z is equal to 3 in equation 4, right? So what is that equal to? Since x and y 0, all the terms containing x and y will become 0. So what it remains, this is nothing but 5 times z square, so that is 9, and then the next term will be 70 minus 25, and the last term is going to be 30 into this 3. This is equal to 14r square. So 45 plus 45 plus 90. So this is 180 divided by 14. So this is nothing but 90 by 7 is r square. So I can resubstitute back value in 4 and we'll get the required equation of cylinder, right? So 4 becomes 10x square plus 13y square plus 5z square, and this is nothing but minus 36x, then this is nothing but minus 18y plus 30z, then minus 4xy minus 12xy xz, sorry, this should be z, plus minus 6yz, then the remaining thing is 70 minus this is 45, and this is equal to 14 times r square is 90 by 7. So this is 180, right? So this is the required equation.